First postulate. Electrons move around the atomic nucleus under the influence of electrostatic forces. As an illustration, the atomic nucleus consists of positively charged protons and neutrons. Meanwhile, electrons have a negative charge. Based on Coulomb's law, electrons will experience Coulomb's force towards the atomic nucleus. This is what is meant by electrostatic force. The resultant force is not equal to zero, causing acceleration. In this case, it is centripetal acceleration. Centripetal acceleration causes electrons to move in circular paths, where the atomic nucleus is the center of the circle. This is what is meant by electrons moving around the atomic nucleus. Second postulate. Electrons can only rotate around the nucleus in certain orbits without releasing energy. This path is called a stationary path and has a certain energy. As an illustration, there are many circles that can be formed with the atomic nucleus as the center. However, not all circles can become orbits for electrons. Only certain circles. This is what is meant by a stationary path. In this path, electrons have certain energy. Third postulate. Electrons can move from one stationary path to another stationary path. If an electron moves from the inner stationary path to the outer stationary path, the electron will absorb energy. Instead, the electrons will emit energy. The energy emitted or absorbed is equal to hf. As an illustration, the following electron is in the third stationary path. If this electron emits energy of hf, then the electron will move to the second stationary path. On the other hand, if this electron absorbs energy equal to hf, then the electron will move to the fourth stationary path. Fourth postulate. On a stationary path, electrons are only allowed to have an angular momentum that is an integer multiple of h over 2 pi. As an illustration, the angular momentum of a particle can be calculated from the MRV equation. In this case, the mass of the electron is constant. The radius of the electron is also constant. Because the value of L is quantized, the value of V must also be quantized. That is, electrons rotate on a stationary path with a certain speed, not all speed values. Hopefully this tutorial can provide an overview of Bohr's postulates. And thank you for watching this video.